Dr. Aileen Burford-Mason is a biochemist, immunologist, and cell biologist. She is an internationally recognized authority on the use of nutritional supplements in clinical practice, including the optimization of vitamin D. Her expertise in the field of nutrition and the role that appropriately dosed vitamins play in the prevention and treatment of disease has been enthusiastically embraced by many doctors and the general public. Addressing such timely issues as immune function, healthy aging, and brain health, her courses and books are clearly written and accessible to scientists and non-scientists alike. She teaches popular courses for medical doctors and other practitioners on the use of diet and nutritional supplements in clinical practice.
So today we're talking about vitamin D as immune system support. And before we actually get into the nitty-gritty of how vitamin D impacts immunity, we need to have a look at how the immune system functions. The immune system consists of a complex network of cells, organs, and molecules. It is intensely complex, immunity. All these work together to protect us from a number of things, not just pathogens like bacteria and viruses, but also toxins and other foreign substances. And the immune system can recognize and destroy abnormal cells, either those that are damaged or beyond their best-by date, or potentially could develop into cancer. And we divide immunity into two components: innate immunity and adaptive immunity. Innate is the body's first line of defense. It involves physical barriers like skin and mucous membranes, and these prevent the deeper penetration of microbes into the body. White blood cells are the main workhorses of innate immunity, in particular neutrophils and macrophages. We call these phagocytes. Phagocytes are cells that can actually engulf, digest, destroy, and then remove infected cells. And there are also natural killer cells. These can directly recognize and kill any infected cells. One important thing to point out is that our innate immune system is intact from birth. The response is immediate. You don't need to have met this particular virus before. But neutrophils themselves are very interesting cells to look at. They're the first line responders. They are the ones that destroy and ingest the invading microorganisms. And in the process, they increase inflammation. So you always got to remember that an active immune system is always generating inflammation. Interestingly enough, a healthy adult has to produce about 100 billion neutrophils daily. That itself depends on nutrition. They don't live very long. They come from the stem cells. It takes them about a week to mature into grown-up neutrophils. And many of them live very, very short lives, 2 to 3 hours. Now, they use what we call pattern recognition molecules to identify the invaders. The most common one, pattern recognition molecules, are called toll-like receptors. These are the sensors of the innate immune system. What they do is interesting. They can recognize a string of molecules that are commonly present on most microorganisms, but aren't present on our own cells. In other words, they can differentiate self from non-self. And so this induces the inflammation, and this is the first step in the immune response. And later on, you'll see how dependent that is on vitamin D. So adaptive, or also called acquired immunity, is reliant on different cells. The white cells called B lymphocytes or T lymphocytes. So B lymphocytes are the ones that produce antibodies. Now, what antibodies do is they will tag a virus and mark it for destruction. So this is a red flag if there's an antibody attached. The T lymphocytes are subdivided into a number of different types. T helper cells, these activate the immune cells. And then we have regulatory T cells, or Tregs. Now, if you learned your immunology a while ago, you would have called these suppressor cells because what they do is they suppress immune responses. And then we have cytotoxic T cells that directly kill infected cells. So the B and T cells, they cooperate to control the immune response. The helper cells will facilitate the B cells producing their antibodies that leads to the destruction of the virus. And the regulatory T cells will block that activity to finish the immune response and draw close under inflammation. So adaptive or acquired immunity we get through exposure to an organism or through vaccination. So looking at the B cells, on detecting a virus, a B cell binds to it. We have many different B cells. They have different receptors on their surface, and one or other of those B cells will recognize this new virus, bind to it, and become activated, helped by the T cells. So that the activation is the signal to start dividing and producing lots of more B cells. And there's a time lag to that because it takes a while to get the cells clonally developing. Most of the B cells will differentiate into what we call plasma cells, and these are the ones that make the antibodies, but a small selection will become memory cells. And these are long-lived cells that really provide a reservoir of cells that can recognize that virus from previous exposure and rapidly respond. So they recognize these are the cells that we want to induce through vaccination. This is just a schematic showing here's the B cells, all with different receptors on their surface. This one happens to have a receptor for the surface molecule on a virus or some other pathogen. This leads to triggering this to start dividing and producing all these daughter cells, clonal expansion. And most of the cells end up as plasma cells producing the antibodies. And here you have a few of these memory cells that are going to provide lasting immunity and a rapid response should future exposure occur. So the important thing to remember about immune responses is it's regulation that's important, not just kickstarting it. So the end of the affair. So once the immune system is activated, as I've said, inflammation is generated, and that inflammatory response is needed to help recruit more cells to the site of the infection and also necessary for healing and fighting off the invaders. If the response is too strong or prolonged, it can lead to damage to the individual, the chronic inflammation, or even to autoimmunity where the body mistakenly attacks its own tissues. The Tregs are the ones that help to dampen down the immune response once the infection is under control. And that's really one of the messages we missed during COVID, is that many people who were in ICU, who were in difficulty, it wasn't the virus that was the problem. The virus was already under control. It was the immune system gone rogue. It hadn't been switched off, and it was generating more and more and more inflammation, which was damaging tissues. So this is just a study if you want to read a review article about how the immune system terminates the immune response. It goes on to talk about inflammation as an active process, and it's needed to be resolved if we're going to fight active processes like cytokine storms, multi-organ failure, acute respiratory distress syndrome, all of which we were hearing as horrible warning signs for people who were ill with COVID. So you have to have a termination to provide autoimmunity. Now, here's one very useful marker in our blood tests that I don't think is utilized sufficiently that can tell you whether the immune system is active, whether it's resolving, the infection is under control and it's calming down, or whether it's ongoing and potentially creating autoimmunity. And that is the neutrophil to lymphocyte ratio. In the regular blood tests, we get neutrophils and lymphocyte counts, and they can be normal, but the ratio of one to the other may not. Remember, the neutrophil is looking at our innate immune response, and lymphocytes looking more at acquired immunity. So this is a study looking at the coronavirus in its early stage, so somebody who just acquired the infection. They says the neutrophil to lymphocyte ratio is a predictive factor for early stage prediction of patients who are likely to develop critical illness. And they say and state quite categorically, if you're over 50 and your neutrophil lymphocyte ratio is 3.13 or more, that predicts those people are going to go on to develop a critical illness and should have rapid access to intensive care. Now, the normal NLR is between 1 and 2. So this can tell you if you had a very active inflammation going on or active infection, it might be 6, and you'd see it come down as the infection resolved. If it stayed up, that's a bad sign. So we need nutrition to keep the immune system from malfunctioning. So first of all, we're going to look at vitamin D. And vitamin D is probably the most critical of the nutrients, but it doesn't work alone, as we'll see. So first of all, vitamin D is critical for innate immunity. It affects how cells divide. It's needed for cells to divide. And it also is needed for another function of cells, and that is apoptosis. Apoptosis is a programmed self-suicide of cells. Perhaps they're virally infected, perhaps they are going on to become cancer cells, and the body automatically deletes them. But it depends on vitamin D to do that. So the effect of vitamin D is cell-specific. In healthy cells, vitamin D helps the healthy cells divide and produce more and more. Think about the neutrophils. And in cancer cells, vitamin D is needed to delete those cells, to get rid of potentially cancer cells and stop the progression. So this is a review of the effect of vitamin D on immune-related disorders. So it says that vitamin D plays a complex role in numerous biochemical pathways involved in immunity. It's needed to produce those pattern recognition receptors, and it's also needed to produce natural antimicrobials that the body can make itself, the immune system makes itself. And without adequate vitamin D, there is no adequate wound healing and the dampening down of the inflammatory response to infection. So I usually like to give you review articles because that can really bring together a lot of current information, particularly when they're current, like this one is. So while vitamin D leads to the stimulation of innate immune responses, it causes suppression of the acquired immune responses, and long-term, it prevents ongoing inflammation and autoimmunity. So it's all about balance, basically. If we look at T cells again, they can be further divided into two different groups, Th1 cells and Th2 cells. The Th1 fight the viruses or the bacteria. They produce inflammation, but excessive activity will cause uncontrolled tissue damage. The Th2, on the other hand, upregulate the B cell activity and make more antibodies. So excessive Th2, though, counteracts the antimicrobial of the Th1. So they are balancing each other out. An optimal immune response requires a well-balanced Th1, Th2 system. Now, I've taken this whole quote because I think it crystallizes what I'm trying to tell you about vitamin D and the immune response. Vitamin D and T cells. So this is a quote from Professor Garsten Giesler, and he was a lead author on a paper in Nature Immunology. And he says, when a T cell is exposed to a foreign pathogen, it has an immediate biochemical reaction and extends a signaling device or antenna known as the vitamin D receptor, with which it searches for vitamin D. This means that a T cell must have vitamin D or activation of the cell will cease. If a T cell cannot find enough vitamin D in the blood, they won't even begin to mobilize. And I want you to remember that when we start to look at some of the studies that have been done in looking at upper respiratory tract infections or autoimmune diseases. So if there's insufficient vitamin D to start off with, then you won't get activation of the T cells. So we learned early on, and we deduced this from our own observation, that upper respiratory tract infections in general, did have a strong relationship to vitamin D. Why? Because we observed that most colds and flus occurred in the winter months, and it didn't matter where you lived in the world, whether it was in the northern hemisphere or the southern hemisphere. When it was winter, there were more colds and flus. So looking at this from a more scientific perspective and not just a generalization, some of the earlier studies, this one from 2010. And I would like to point out that I think 2010 was about our peak interest and excitement in vitamin D, where we were discovering how many people were actually deficient in vitamin D and therefore had compromised immune responses. Since then, things may not have been clarified, as we'll see. So this is a study in 430 Japanese children from the age of 6 to 15. And they were given a fairly modest dose of vitamin D, 1,200 international units, or placebo over the winter months. And that's important because some studies study some people in the winter months, some people in the summer, and that is not appropriate. They did actually prove, in this study, they had to prove, not just take word of mouth that the person had flu, but it had to be laboratory confirmed influenza A. So what they did find was an effect, a statistically important effect of this smallish dose of vitamin D. Flu occurred only in 11% of the vitamin D group, compared to nearly 19% on placebo. Now, concurrently, some of these children had asthma. And what they also found was the vitamin D helped reduce the number of asthma attacks. Only 2 occurred in those who were on D, but 12 on the placebo. This is another study in Vietnam. Healthy children, again, it's important to note that they were healthy, and adolescents 3 to 17. They were given 2,000 a day, but they were given it just as 1 weekly dose of 14,000 or placebo, and they were followed for 8 months. And they found that definitely they proved that that dose did increase the vitamin D levels in the intervention group, but there was no change in the placebo group. It went from 65.2 to 65.5 nanomoles, so no significant change. But they did find a reduction in the influenza group, in the vitamin D group, but it was not statistically significant. But there are other respiratory infections apart from influenza, and they were reduced by about 19% if they were taking vitamin D. Now, again, this is a third study, and this is done in Bangladesh. So these were hospitalized children, and they wanted to know if they had pneumonia, could they give them a big dose of vitamin D and see if they had a reduction in the stay in hospital and the time it took for them to recover. So anyway, they were given pretty large doses these were between the ages of 6 months and a year, and 59 months. So they're given various doses depending on their age. And then after that original big dose, they were maintained for 4 following days on 10,000. And what they found was only the children who were vitamin D sufficient at the time of hospital admission actually had any reduction in the duration of their stay or the time to recovery. But what they also noted was that there was a high incidence of malnutrition in general in the population. And certainly they got an adequate increase in the vitamin D, but it may not have been sufficient to impact these children because of the concurrent malnutrition. So this is looking at adults, again, taking healthy adults and saying, is the amount of vitamin D you've got in the blood going to impact the incidence of viral infections, respiratory tract infections you've got? And it's a relatively small study, and it was conducted over the winter months, which is appropriate. And what they found was you needed a concentration of 30 nanograms per mil. Now, in the US, that's the units you use for measuring vitamin D, 25-hydroxy-D or nanograms per mil. In many other places, including Canada, it's nanomoles per liter, so that would be 95 nanomoles per liter. And if you had those blood levels, it was associated with a twofold decrease of actually getting the infection and a marked reduction in the number of days ill. So then we get systematic reviews. This is where you lump together all studies and see if you can draw a general conclusion, remembering that the studies may have been designed differently. So when they looked at 25 of these studies and analyzed them together, what they found was no matter what was the study design, all studies and all doses of vitamin D gave a modest 12% reduction in respiratory tract infections. But those people who were given daily or weekly vitamin D doses, there was a 19% reduction, but no benefit of a bolus. That means a large amount given at one instance or monthly dosing. And in fact, personally, I think that weekly dosing isn't even appropriate. I think daily dosing is more efficient and effective. For those people who started off with very low vitamin D, in other words, they were deficient in vitamin D, there was actually a 70% reduction in respiratory tract infections. So low dose, low blood levels are the people who benefit the most. So let's look at COVID then. And this is basically a systematic review and meta-analysis of vitamin D. There were hundreds of studies done during COVID. I have to say most of them were abysmally badly designed and perhaps need to be ignored. But this looked at all of them. And the quote from the paper is, vitamin D supplementation did not reduce major health-related outcomes like mortality, ICU admission rates, or mechanical ventilation. But, it goes on to say, the studies differed significantly with respect to their design, the drug dosage, and the population characteristics. So are some of them from a malnourished population, some of them from an adequately nourished population. The intrinsic heterogeneity of the included studies and small sample sizes make it difficult to interpret and extrapolate this data to a large population. So we're not getting no general advice based on the studies that have been performed. Now, what has been recently shown, and I think it's important to see, is that giving large doses is not the answer. You can't get someone who is deficient in vitamin D and just shock their system with a huge dose. So this was looking at a single high dose of vitamin D in COVID on length of stay or the actual severity of the disease. And it was 200,000 international units of vitamin D given as a bolus. And what they found was that it did indeed increase the blood level up to the sort of level we seen giving statistically important positive results. But there was no difference. There was no statistical difference in in-hospital mortality, admission to the intensive care unit, length of hospital stay, or the need for mechanical ventilation. So this again is, people have been using studies like this to build a story. Vitamin D is not important. So this was a little bit later, and it talked about vitamin D. Where are we now? Let's look at it and see. We've seen all of these studies being rushed into print, and they seem to be so wildly different one from the other and coming up with different conclusions. So they reviewed 11 of these randomized control trials and its impact in COVID. Again, they said they were so different, wildly different one from the other. 5 did have a placebo control. 6 were open label. In other words, they were just giving the vitamin D. Everybody knew whether they had it or not, or single blinded, where either the doctor or the patient knew and the other person didn't know. There was a wide range of sample sizes. Some of them had only 30 patients in their study, and others had up to 500 or 600. So various lab measures of vitamin D were used. Now, I have to tell you, there's really only one validated measure. Some were using vitamin D itself, looking at that in the blood. That has a half-life of 1 day. That is very inaccurate. 25-hydroxy-D is the measure of choice because it'll probably last up to 3 weeks in the blood. 125-dihydroxy-D is the hormone that vitamin D eventually becomes, and it again has a much shorter half-life. So because of the variety of outcome measures, then you have another complicating factor. Some looked at mortality, some looked at length of hospital stay, some looked at the need for intensive care, the resolution of symptoms, or whether they cleared the virus. Some looked at a number of these, some looked at only one of these. So the conclusion where we are now is the lack of a consistent protective signal from randomized controlled trial reporting so far is reflected by the absence of any recommendations. So nobody has been able to say, you need to take vitamin D and this is how much you need to take, this is how much you have in your blood, because there have been such wildly different results from clinical trials. This is a very recent study that has looked the really most severe outcome measure is mortality. And that was what was so disturbing and concerning in the initial stages of the pandemic. And this meta-analysis quite clearly shows that there is a significant reduction in mortality. So there are 19 randomized control trials they found. And they weren't biased. We'll talk about bias in a minute. So they seem to be free of bias. And there was a significant reduction in all-cause mortality because some people who died of COVID were actually dying from the diseases they already had. Whether they had heart disease, they could have a sudden cardiac arrest, etc. But vitamin D seems to reduce all-cause mortality by about 28%. But when you looked at the very severe cases, the people who had severe disease, did they die or not? The reduction was dramatic. It was 43% reduction. So there is definitely a role to play of vitamin D alone. So we've got to go back and say, well, these vitamin D clinical trials, where are we going wrong? Because it's really important that if we're going to go on studying vitamin D and show that our instincts are correct, that vitamin D is critical, that we have good levels of vitamin D, we have to study them properly and not waste time and money studying vitamin D in a way that gets dismissed as inappropriate later on. So the randomized control trial, I think, is the major problem. Let's look at randomized control trials. They're the gold standard in clinical research. And many of the recommendations by groups like the Endocrine Society in the US that have recently released recommendations have said they really will only consider randomized controlled trials. Any other way of looking at vitamin D, they're not really interested in. And that's because they're the gold standard of looking at drugs. So in a randomized controlled trial, you separate participants into, they're randomly assigned either to a treatment group or a no treatment group. And that helps eliminate bias and ensure that the groups are comparable. And that's the only way, if you do this, that you can be sure that one drug works compared to no drugs, etc. The other type of studies, observational studies, they study something in a real world setting. So you're looking at two variables, vitamin D and disease. But you're looking at participants in their natural state, and you're not intervening. You're just observing them, how much vitamin D they've got, what is their exposure to vitamin D, and whether they develop a disease or whether they have it or not. So a good classic example is smoking and lung cancer. So that was an observational study. The more smoking, the more lung cancer you saw. So what you find when you look at observational studies of vitamin D, almost exclusively they show that poor vitamin D status is a major risk for any chronic disease you want to look at, including immune diseases. So here are the problems with the clinical trials of vitamin D. There can be no true control group. A true control group should have zero amount of vitamin D in their blood. That is lethal. You have to have some vitamin D. So you're always looking at groups where you have an intervention and then you have a control group with varying levels of vitamin D already in their blood. This is blurring the boundaries between the two groups. So even if both groups start off with similar blood levels, there's no guarantee that the controls don't get extra vitamin D, either from sun exposure or supplements. You cannot lock people up for 5 years and say you're not allowed to go out in the sun. So basically, that's another variable that you can't control from. Of course, in drug trials, no participant has access to the drug under test. So many other factors come into play here. Your basic, as we saw in some of those studies in influenza, your vitamin D status matters. So if you're put into a clinical trial and you're deficient, they should know that, but they don't. They're not testing the blood necessarily. So they're saying, well, you may have deficient levels or you might have sufficient levels. That is not an adequate way to test vitamin D. And dose matters. Trivial doses of anything will show no benefit. An example I like to give is we know that one major factor in terms of health is economics. So the poorer you are, the more likely your health is to be poor. And so if you were studying health and finances, if you say, oh, these people, they're below the poverty line, we're going to give them an extra $1 a week to see, or an extra $1 even a day. Will that improve their health outcomes? No, it's too little to make a significant difference. So it's the same, dose matters. Trivial doses will show no benefit. Blood levels matter. It's amazing that many of the clinical trials don't even check the blood levels. They just give an amount of vitamin D and look at outcomes. And then the last thing that really is mostly ignored is weight matters. Overweight or obese people show no benefit. And there's a study there from a recent study from JAMA. And the reason for that is that the vitamin D isn't circulating. It's tucked into fat cells. And so it's not impacting organs and tissues. So there's another problem then, and that is very common, and it's called implicit bias. So implicit bias is where you have attitudes or beliefs without being consciously aware of them. And when you're reviewing something, basically you should review the literature impartially with an open mind and then draw your conclusions. What can happen is that people already have a mindset that says, I don't think this works. And then they can selectively cherry pick studies that confirm that. So if you have implicit bias, you might be inclined to give more weight to studies that align with your biases and dismiss contradictory evidence. So again, a fairly recent article looking at the randomized control trials that already exist says large vitamin D randomized control trials have been designed and conducted over the last few years. The vast majority of these did not restrict their study populations to individuals with vitamin D deficiency. And some even allowed moderate vitamin D supplementation in the placebo groups. Up to 800 international units a day have been used in some of these studies. In these randomized control trials, there was no significant impact on the outcomes they were measuring. And not surprising. So I first got interested in immunity and nutrition way back in 1979 when I read this paper by the late great, unfortunately, a researcher who was an endocrinologist and immunologist, David Horban. And he wrote at that time that T cell function, remember how important T cells are in this, depended on key nutrients. And he highlighted vitamin C, the B vitamins, especially B6, zinc, and essential fats, the omega-3s and the omega-6s. He didn't highlight vitamin D because we really were asleep at the wheel with regard to vitamin C way back then. It wasn't until the 90s we started to get really, and early 2000s, that we started to get excited about vitamin D. What he said, though, is what influenced me. He says inadequate intakes of any of these will compromise T cell function. And also be aware that megadoses of single nutrients will only be minimally effective if intakes of other nutrients are inadequate. So think back to the studies we've just looked at. If we saw an impact of vitamin D, it was not as great an impact as we might have seen if all the other nutrients were also optimized. And that is something that is extremely hard to study. So please remember that vitamin D is not a drug, and it shouldn't be tested like a drug. Vitamin D is a vital component of the complex apparatus we need to manage appropriate immune responses, to fight infection, prevent colds and flu, control inflammation, prevent the development and progression of autoimmune diseases. So it is vital, but it's only one component. Vitamin D doesn't work alone. Vitamin D supplements will only be minimally effective if there are coexisting deficiencies of other nutrients, vitamin C and magnesium. And in finishing, I'd really like to say that it's surprising we've had any positive, given the state of nutrition in the world today, it's surprising we've had any positive studies from vitamin D, which shows how critical it is. So I just wanted to also say, if you are interested in nutrition in general and immunity, you might be interested in looking at my current book, which is The War Against Viruses, How the Science of Optimal Nutrition Can Help You Win. So I thank you very much for your attention.